Awesome. Welcome, everyone. My name is Dev DeVred. I use he, him pronouns. I'm an Associate Dean of Admissions here at Reed, and I will be your moderator and host for this session today. The session is all about the math and statistics major here at Reed College. I'm going to pass it over to our math faculty. Maybe we'll start with Michael and let you do your introduction, and then over to Angelica, and then we'll go from there.
Wonderful. Thank you, Dev. Hi, everyone. My name is Michael Pearce. I'm an assistant professor of statistics here at Reed in our math and statistics department. So I work in various types of applied statistics. My research specifically focuses on developing methodologies for analyzing data or problems in the social sciences. So this takes, a few different forms. Something I've done historically is work on statistical demography problems, where demography is the study of sort of human mortality, fertility patterns, how this maybe varies over time or across geography. So work on forecasting life expectancies into the future, things along those lines. More recently, my work has been developing problems to working with ordinal data. An example of this would be something like working with ranked choice voting data. And the implications this has when we're thinking about various systems of aggregating rankings for the purpose of making collective decisions. And this relates a lot of time to questions over fairness and equity when people provide rankings as a manner of expressing their preferences. At Reed, I work with thesis students. I teach a variety of courses here. These range from introduction to statistics to machine learning to Bayesian statistics, where I'm a Bayesian statistician, one paradigm of statistics, as well as a whole host of other things I may be teaching in the future. I guess that's all I'll say for now, and I'll pass it to Angélica.
Hi, so my name is Angélica Osorno. I'm a professor of mathematics here at Reed. My research area is something called algebraic topology. So maybe this is a little bit harder to explain than what Michael was saying. So topology is a study of higher dimensional surfaces, and in algebraic topology, we use algebraic methods to try to understand the surfaces. I'm going to leave it at that. But in addition to doing my research, I also I do research with students, and I can talk a little bit about that if people want. And I teach all sorts of classes, starting from calculus all the way to upper level electives. And I'm happy to talk about more of those pieces. But maybe this is something to just say here at the beginning, is that most faculty teach across the curriculum, except for the sort of like mathematics statistics kind of split. And so that's us, and we're happy to answer questions as you have them. We thought that we would actually start by telling you a little bit about the major structure. And before I get started, I should say the mathematics and statistics department houses a major in mathematics, a major in mathematics with concentration in statistics, and in addition, we have standing interdisciplinary major with computer science. So our plan is to tell you a little bit about those, and again, we're happy to answer more questions as they come. So I'm going to start sharing my screen. So that's us. Just to tell you about the mathematics major, this is the idea behind the curriculum, and I'm going to just give you a broad idea. So it starts with calculus, and something that's different than in many places is that we only have one calculus class. So we do a little bit of derivatives and a little bit of integrals and kind of applications in that class. Then that feeds into an introduction to analysis class. If you've never heard what this means, like analysis is kind of like, let's do calculus rigorously. Let's prove all the things that you may have used in calculus. So let's define what it means to have a limit from the beginning. We might actually go a little bit further back and construct the real numbers, or prove that the real numbers have like whatever properties we think they have in order to do calculus with them. And then we have another 100 level class, which is discrete structures. And we really sort of think about intro to analysis and discrete structures are foundational classes where we're doing two very different types of mathematics, but at the same time learning about how to prove things. So one thing about Reed is that we are doing theoretical mathematics from very early on. So we're proving statements and asking students to prove statements from the beginning, from those 112 and 113 classes. And then we have our linear algebra class. You may have taken a linear algebra class, for example, if you've done some dual enrollment classes at a community college. But here again, our linear algebra class is a proof-based class where we prove all the theorems, and we ask students to understand those proofs and to prove some things themselves. Then our vector calculus comes after that. So here's where we do calculus in 2 or more variables, and again with proofs. And then as part of the mathematics major, we have 2 300 level classes. By 300 level classes is classes that you will probably take your junior year, that are required. One is a real analysis class. So if you think that analysis was like, let's do calculus seriously, here we're pushing this and really proving a lot of like very interesting things about kind of like the doing things continuously in the field of real numbers. And then abstract algebra is our other 300 level class where we really kind of taking the abstractions of linear algebra and pushing them even harder. So all of these classes are all, except for calculus, they're all proof-based, and they're really like kind of the foundation of our mathematics major. And then in addition, students that major in mathematics need to take at least 3 other 300 level classes. And here I'm just giving you a list of the different classes that we offer, and I can talk a little bit more about those if people want. So that's the mathematics major.
Okay, so next is statistics, and I'll repeat this again. The statistics curriculum here at Reed is actually part of a mathematics major with a concentration in statistics. So the students that come away with this, that have gone through this curriculum, I think come away with a really broad set of tools, which are really valuable. They not only get the sort of toolkit of being a statistician or a data scientist, so learning about regression of various kinds, some methods in machine learning, classification, thinking about model selection, the realities of working with really messy data. They also get the mathematical underpinnings of these tools, and that strengthens their knowledge of how people can use or misuse statistics in the real world. So looking at the top 2 lines here, you'll see that much of this is the same. The students who go on this path take the same courses. They go through the calculus sequence, they see analysis, they see linear algebra, they see discrete structures, but they also take courses in probability and mathematical statistics, these being sort of mathematical foundations of the broader field of statistics. We separately have some courses that really focus on the statistics or data science side. So this starts with our course 141, an introduction to probability and statistics. This looks somewhat similar to what you maybe have seen if you've taken AP statistics, but we also do quite a bit of coding and an introduction to data science in that course. So you'll really get a strong understanding of how to work with data in R, and not just the nice data that is in the ideal world, but also data that includes rows that are missing or variables that are missing, situations where we have to manipulate data to actually get good insights out of it. Once you've taken this course, the world is your oyster in a sense. You can move into our 200 level course on data science, which covers more complex ways to visualize and work with data, such as working with text data or location data, interactive tools, things like that. And we also have this course in statistical learning, which is meant to suggest something to do with machine learning, but from the perspective of the traditional statistics community. And then at that point, you can take a variety of upper level statistics electives. These follow the research areas of the statisticians here, as well as some research-based courses. So Bayesian statistics, this is my field of study. My colleague, Lenny Weinstein, he works in causal inference. This is the idea of trying to extract causality from data that is observational. And then finally, practicum, working with other faculty around the college on their research projects and carrying out a long-form research project for them. So I think that all 3 of these present really exciting opportunities for students to like really get their hands dirty with data and trying to present or find research insights from that.
So as I said, we also share the computer science and math interdisciplinary majors. So something that you may have learned about Reed is that we have some interdisciplinary majors that are that are there. And so this one is one that is very well established. It has a very well established curriculum. And one of the cool things about this one, I said that from the get-go, is that if you do a computer science math interdisciplinary major, your thesis will be done alongside a computer science faculty and a math faculty. So you actually get two advisors. And so that's something that it's kind of unique. As you notice, the beginning looks very much the same, right? Like you have calculus, analysis, linear algebra, district structure, vector, and maybe I should say those are all required. And then students get a choice between vector calculus and abstract algebra. And then in addition, there's a computer science classes that students must take, which is the intro computer science class, the CS 121. And then another very much CS class, which is the fundamentals 2. And then in addition, students must take algorithms and data structures and comp, which is like short for like computational complexity. And then in addition, computer systems. And I should actually say that this two classes, 382 and 387, are actually cross-listed between math and CS. So these are classes that you could take as a math major or you could take as a computer science major, but also they are actually required for the interdisciplinary major. And then in addition, students must take a certain number of upper level electives, like from one or the other department. And I'm going to say this again, I'm going to emphasize that these one, you actually get two advisors, and it's really expected that the thesis will be using both fields thoroughly. So those are the majors that are housed by the department. There's also ad hoc interdisciplinary majors that students can do, like math and some other major, and join them together, and we can talk a little bit more about that if people have questions. I already alluded to this, but at least from the mathematics side, except for calculus, our classes are proof-based. We're really expecting students to learn how to write formal mathematics and how to express formal mathematical thoughts, to be creative in coming up with new proofs. And that's something that we kind of expect, and we teach you how to do from the beginning. I don't know if Lenny wants to say something about the nature of our stats classes. That maybe something you haven't said.
Yeah, sure. I think that on the statistics side, we really leverage the mathematics training that our students have by ensuring that in the cases where it's appropriate, really working through the proofs of important statistical concepts. But for every statistics course you take, we also really focus on the computational or applied side of the work. So there's never a course in statistics in which you only work on pen and paper. We're always interested in thinking about how we could prove something in R, or get intuition for what's going on in the real world via a simulation, for example. So even in the courses that are more traditionally on the math side of statistics, such as probability, we still are using computation and coding throughout to make sure that when you leave here, no matter what you want to do, you still have a really strong basis on that really practical side of statistics.
I already said something about interdisciplinary majors. I'm gonna just say a little bit more. So if you're interested, for example, in doing like a math biology interdisciplinary major, then you actually work with faculty from both departments to create a program of study. It needs to be approved for both by both departments, and this is not unusual. There's a lot of students at Reed. I mean, there's a reason you're choosing to come to a liberal arts college, where like you really maybe have varied interests, and there are many ways in which we can work for you to be able to learn from both. And interdisciplinary majors are one of them. And since I've been here, I've seen math political science, math philosophy, math biology. So there's many examples. Of course, like math physics is not uncommon for students to want to do, and so we just work with the student to make sure that we create a program of studies where we really feel like the student is engaging thoroughly with both sides of it. Many of us do summer research with students. I'm actually very excited this summer. I'm going to be working with 6 students. We have sources of funding to make sure that students can get paid for doing research with us, and many students also go elsewhere to do summer research opportunities. It's very common in mathematics and in statistics to go and do research elsewhere, and these are usually funded opportunities where you actually get paid for doing like 8 to 10 weeks of summer work. Some of these experiences end up in research publications, and that's actually pretty nice if you're trying to go to grad school later on. But also, even if that's not the case, just like the experience of doing research and figuring out if that's something that you want for yourself, like that's something that is very valuable, and students do it a lot. But other students just also want to use their summers to maybe try working in a specific industry. So they'll get internships in tech companies, or maybe like financial companies and things like that. So that's also something that students do over the summer. Do you want to talk about thesis, Michael?
Sure, yeah. So if you haven't heard, the thesis is really the culminating, defining aspect of a re-education. Thesis projects really vary quite a bit. Angélica and I have already sort of alluded to, various types of thesis work that we've done. I think that something really powerful about our program is that each member of the math and stats faculty has a relatively small number of thesis students, so we really dedicate a lot of time to the project and trying to make a project that really suits the students' interests as well as our own. Sometimes these are in the direction of a publishable research project, maybe not at the end of the school year, but maybe with a little bit more work they could be. Other times they're ways for a student to explore something that they're interested in that's maybe not part of the curriculum, or going a little bit deeper into something that is mentioned or a small part of the curriculum. So currently I'm working with two students on thesis projects that are offshoots of my dissertation work that I did for my PhD. They're a mix of working with new methodologies, working with strange or unique data, putting this all together into a serious project that ends up being bound and put into a tower in our library here. So this is a really big, important aspect of our departments and of Reed in general.
Yeah, and maybe just to add a little bit, so in mathematics and statistics, some people do original research as part of their thesis, but some people use this as an opportunity, as Michael was saying, to really learn something new, right? And maybe nothing of what they write is original, but they're still like, it's their own take on their process of learning something. So one of my thesis students right now really wanted to learn about how manifolds are connected to higher dimensional categories. And if you don't know what those mean, that's perfectly fine. But like, imagine all the process of like his years of being at Reed took him to being able to understand this question, and then he really is using the time of the thesis to really learn these two subject areas that are kind of like a priori seem like really dissimilar, and then like figuring out like how people have managed to connect them. And this year as well, I have a computer science math interdisciplinary major who's using ideas of category theory, which is some very abstract mathematics, to understand certain proofs in cryptography. So again, blending this kind of ideas. And this student is actually doing a lot of original research as part of her process. So you can have like just expository thesis, and on the other end of the spectrum, original research, and we have everything in between as part of this process. Study abroad, we actually have a couple of establishing study abroad programs in mathematics. So the classical one is the Budapest Semesters in Mathematics. So this is a program that has been going on for many years. We know their curriculum very well, and they know our students very well. So every year we have at least a couple of students who go for a semester to Budapest. It is a very enriching program. It's like the classes are all taught in English, and students come back with like this broad view of mathematics that we cannot really offer them here. The other one that we have as a established study abroad program is a new one in Guanajuato in Mexico, that it's more sort of like applied math, kind of like towards the side of statistics. And this one is a relatively new program that was established within the last 5 years. And we've only had one student who has participated in the past, but excitingly this year we just officially approved it as a standing study abroad program. So that means that we understand their classes, we would understand how those classes translate to read classes and so on. But students also kind of create their own, so it's not uncommon. I actually just heard one of my students is going to go to Australia for a semester. She found that opportunity herself, and then as part of that, she has to work with us to figure out what the classes that she takes there, how they're going to transfer back to read classes. So there's also the opportunity to find your own study abroad, and then just making sure that like it works with what we want you to be doing. So that's another option. And the last piece of information that we wanted to share with you, what do our graduates do? So we have a lot of students who go to grad school, but that's not the only path. We have students, most students like straight out of graduating either go to grad school or they start working in industries that are close to what we do in mathematics or statistics, right? So like they might work in the tech industry, maybe doing some programming, and we encourage our students to take computer science classes because that's going to be helpful for that. Or they might become data analysts at various places, or maybe they work as quants in like some like banks and things like that. But other students just like they want to do something else. We have students who become high school teachers and then go into like a master's for education or things like that. And then if you look back, like people who graduated more than 10 years ago, like there's people who've gone to grad school, for example, to law school, right? Or there's people who like maybe gone to grad school in political science or other things, and they didn't have a degree in political science, but they had taken enough classes that read in political science to be able to do that. So things of that sort. But yeah, one thing that maybe I should say is that if you have a mathematics or mathematics with concentration statistics degree from Reed, that signals that you know how to think deeply, and maybe you're not quite going to use the mathematics that you learned, but you're definitely going to learn. You're going to use the ways that we learn about things, and that's what our graduates take out of being with us. I don't know if you want to add anything, Michael.
No, I think that really covers it. I'll say that I just was chatting with one of my thesis students today, and I found that he just got a job working in as a quant at a healthcare company. So I'll say that that's an example of someone who did not go on to grad school, and he found an incredible opportunity for something that he wanted to do. So there really is a lot of variety in what our students do, but as Angélica said, I think our program like really sets you up for success. Maybe not that you need to go into mathematics or statistics, but you could do a whole variety of things just with the skills that you've learned throughout our courses.
So I'm going to stop sharing screen, unless I'll bring it back up if anyone has a specific question about the slides.
Awesome. Thank you so much for that presentation. I think that was beneficial. I don't know, especially if you're like me and needs to see it visually. That was helpful. I also put the link to the math program site on the chat box as well. So a lot of that information is also on the website. But let's go to the questions that were asked in the chat box. So let's see, let's start at the very beginning here. What new skills will students who have done well on the AP Calculus exam develop by retaking calculus classes at Reed? And if you could also maybe talk a little bit more about what the exams look like at in the math program, and what does homework typically look like in this program as well?
So if a student takes AP and gets, I'm gonna get this wrong because I never remember. I did not take the AP exam because I did not study in this. I did not do high school in this country. But if you do the AP AB and get a 5 or get a 5, and if you do the AP BC and get 4 or 5, I think I may have gotten this wrong. So double check on the website that Dev put up. You do not need to take our calculus class. You actually place out of it and you can start straight in 112. And even if you don't do AP, but if you took a calculus class and you think that you really know it, we actually have a placement system, which is not a placement exam. We actually have a placement conversations where we talk with students about where, like, what kind of things that they've learned and where we think they should start their math journey. So if you took calculus, maybe not AP, but like a serious calculus class, we'll probably tell you, well, maybe you should just go ahead and start in 112. So yes, our class, our one semester class doesn't cover much more than the AP calculus classes. So that's the first thing that I should say. Some students might just still benefit from taking it if they were a little bit shaky on their calculus when they were in high school, or if they just want to like start a smooth transition into college, right? Like starting college is tough, so you might wanna start there. So that's just something to be said. And maybe I should add, we have similar policies for IB credit and the A levels. So that's something useful to know. The other question about exams and homework, it kind of really depends on the instructor. Every instructor has different personalities in terms of the exams. But let me tell you, for example, in my case, like, so right now I'm teaching 113. And so this is the discrete math class. It has no prerequisites. You can just take it straight out of high school. And in discrete math, we're learning a little bit of the mathematics of counting, a little bit of discrete probability. We do a little bit of graph theory. We do a little bit of baby number theory. And so my exams are just in-class exams, 50 minutes, but I try to design them so that it really should take you more like 30 minutes to complete them. And they're closed book except for a cheat sheet. And the idea for me is that, like, I don't need you to memorize things, but I need you to understand them fairly well. And in my exams, you have to prove things, right? So I might ask you, prove by using this method that this is true, right? And that the exams are actually easier versions of whatever you did in your homework. So going to the homework question, the homework in my classes is like, prove things and explain things and write things in full sentences. So I don't want to see as solutions to my problems just like a number, right? I actually want to see full sentences that explain to me like why that number is counting whatever I'm asking you to count, for example, if it's a counting kind of question. And in general, for like beyond calculus, we are expecting full sentences and proofs as part of our homework. Very few like there's some calculations that we do as well, but it's mostly just proving things. But things are different statistics, so Michael can answer that.
Yeah, well, in some ways they're different, of course, but in many ways they're very similar. I'll say that, like Angélica, I think that my exams are generally a little bit easier than my homework, but they follow the same sort of patterns. My courses tend to have some level of like mathematical questions in which we actually, work with equations and we think about properties of models we might be working with. But I think the bulk of the work always comes down to the sort of art of statistics, so the actual complexities of working with data and thinking about how we interpret the models that we work with, how they could be used in practice, thinking about some ethical implications of our work. And this happens on the homeworks and on the exams. So in an exam setting, oftentimes I do mine take home. This means that they become open book, sometimes even open internet. I understand that in the real world, being a statistician means that you can look up tools, but it's really hard to look up on the internet like precisely how you correctly interpret something, especially in specific or sensitive contexts. So a lot of my exams are testing those sorts of skills in addition to the mathematical underpinnings of the methods that we're working with.
Okay, thank you both. And then this next question is from a student who has some interest in engineering and wants to know how well the mathematics computer science interdisciplinary program works for someone who's interested in engineering, in particular mechatronics.
Well, that's a tough question, but maybe I should say that it depends on the type of engineering, right? Engineering comes in many different shapes and forms, but like I bet you that for mechatronics, you might actually want to consider doing rather than math CS, you might want to consider doing like physics CS or maybe math physics, right? And maybe I should say that in general, for like if you're thinking of going to grad school in some type of engineering, so we don't offer any engineering at Reed, right? And some people, some of our students do go and do grad school in engineering, and the important thing is to know what classes they want you to be taking rather than what degree you want to have. And if it's a bunch of like math and physics and CS classes, then maybe doing an interdisciplinary major where like you maybe still have room. And maybe I should say that like at Reed you have to graduate with having taken 30 units of classes. But the math major itself, like if you actually look at the number of classes it requires, it's like probably, I can't remember it, but it's probably like on the order of like 12 or something like that. And then if you add the distribution requirements, you still have room. Like there's like at least like 4 to 6 classes that you get to choose what they are beyond the group requirements, beyond the math major requirements. So you can actually choose those to be whatever you think you're going to need for whatever program you want to do. We also do have the 3-2 programs, and I don't know how many of you have heard about this, but this is where you do 3 years at Reed and then 2 years at, like, for example, an engineering program, and you get a master's out of that one. It is actually not that common to do, even though many students come thinking that they want to do it. And one of the reasons it's uncommon is because you don't do thesis. And I think a lot of students come to Reed because they want to do thesis. But students do it. And so like, for example, they might do 3-2 with mechanical engineering at Columbia University or something like that, right? And so at that point, if you come to Reed deciding to want to do that, you're going to meet with someone who's going to help you figure out what's the best route. It tends to be, for engineering, it actually tends to be a physics degree, unless it's like more like electrical engineering. In that case, like maybe a computer science degree might be more, might be better.
I'm gonna put a link here in a second to some more information about the engineering program. Just to clarify, it's actually not a master's program. It's a 3-2, it's 2 bachelor's degrees. So you get a bachelor from the partner institution. We have 3 partner institutions. We have Columbia, Caltech, and Rensselaer. And then you also get a bachelor's degree from that partner. So one from Reed, one from the partner institution. So you get 2 bachelor's degrees out of it. But everything else, and Angélica said, was spot on. I think it's a cool route. But there's a lot of conversation that has to happen in order to pursue that route. But I'm going to put a link right now. Awesome, thank you. Another question that's specific to this individual student, but I think kind of talks a little bit more about this idea of interdisciplinary majors here at Reed. How well will the mathematics and or sorry, I already asked that question. The student is curious about the path available for someone who would want to use math and physics to chart the fabric of space and time / higher dimensional things. Is that something that one of you could address?
Yeah, I mean, I think I don't know from the physics side, but from the math side, you definitely want to do maybe some topology and some differential geometry. And I mean, we have our topology class. That's a 300 level class that has vector calculus and abstract algebra as prerequisites. So you usually, most students will take that either at the end of their sophomore year or at the end of their junior year. It's a class that we offer in the spring. And so if you're curious about that, you probably want to do a math physics interdisciplinary major, and you're going to work with both departments to figure that out. And if that's something that you're really curious about, we can probably explore it as part of your thesis, right? Although maybe you get to explore it a little bit earlier as part of a summer research experience with someone. So this one's is very topic specific, so maybe I'll just leave it at that. But again, you can, if you come here, you'll work one-on-one with faculty. They'll be happy to answer whatever questions that you may have about these kinds of things.
The next two questions are fairly similar, but can you maybe elaborate a little bit more on what research in the program looks like for students, in particular research outside of Reed? So what kind of opportunities do students who are wanting to do math can do research outside of the institution? And then what do some of the thesis some additional thesis projects maybe in the math program look like?
You want to get started, Michael? Or do you want me to take that?
Do you want to get started first, and then I'll tack on?
So let me start by saying that if you actually Google math REU, so that's REU stands for Research Experience for Undergraduates, you will find at least 50, if not more, different programs that run mathematics research experiences for undergraduates. And this is actually a special tag that people can use when they're getting funding from the National Science Foundation to run this experiences for undergraduates. And these tend to be open to anyone, any undergraduate in the US, and they really they have a wide range of topics that they cover. Many things that we don't have any experts that read, but things that like maybe I could be working on as well. So there are tons and tons of these opportunities in all sorts of like different areas of research, of mathematical research, including pure math, applied math, statistics, and everything in between. And they tend to be research projects that are designed so that undergraduates can access them. For example, when I do research with undergraduates, I have my esoteric research in algebraic topology, but I can carve pieces out of it that where I can, like, maybe the question doesn't use any advanced techniques. So in order to understand the question, I need to know the advanced techniques, but in order to answer the question, I can translate it into things that my students can work with very few prerequisites. And so my students can do very hands-on work. Maybe I'm trying to prove a conjecture where generating a lot of like initial data by writing some computer code might actually be a beneficial thing. And then we look at it and then we like look for similarities and patterns. And then we realize, well, maybe these things are connected, and then we actually prove it. And then that becomes a research paper. And then a lot of the times, like, as I said, like maybe our students at the level cannot really understand that the importance of this within my research area, but they can still do the work, and we can still produce a research paper.
Yeah, so on the statistics side, I think the same principles hold true. So there are REUs in statistics. There's projects working here at the college with statisticians or with other folks in other departments who have statistical questions. I'll say that some of our students who take some of our introductory or intermediate statistics and data science courses, but maybe have majors in other departments, end up using statistics quite a bit in their REUs that exist, in other disciplines as well. When it comes to actually doing statistics research, I think that because of the fact that our students have a really strong mathematical foundation in our work, they're really well equipped to do a whole variety of things. So sometimes this comes down to studying theoretical properties of certain models that we have, but I think more often it comes down to the idea of saying, like, let's actually get data from someone who works in some field. Maybe this is a psychologist or a biologist or a chemist, and do a complicated analysis for that person, that researcher, that maybe they don't have the specific training in. So, here, one of the things we cover in our intermediate courses is working with mixed effects models, which is a class of linear regression, which is somewhat complex and comes with lots of assumptions. These models can be hard to fit, and thinking about everything that goes into it is not something that you would cover in a chemistry class ever. So then we could take that data and come with some really actionable results for that scientist. So oftentimes research in statistics follows that flavor.
Thank you. This next question might also be a CLBR question, which we can talk as well, but what percentage of math students go to grad school or PhD?
I don't know exactly, but anecdotally, I want to say between 10 and 20%. And there's the question of like how many go immediately after they graduate and how many go like within a few years, and it's probably somewhere around there, but probably CLBR, the Center for Life Beyond Read, has more precise information.
Yeah, my perception is the same as Angélica's. Admittedly, this is only my first year here, so I can't speak to a historical trend. But certainly our students are well equipped to go into PhD or master's programs in statistics, and the students who apply have had great success.
Great. Yeah, so the CLBR, that's the Center for Life Beyond Read, they're the office that works with students to help them navigate opportunities outside of Read, including internship opportunities, job opportunities, graduate school, some sort of grad PhD program. They do the advising around like medical school or law school advising. So that's the office that sort of houses that. So that statistic might be a question for them. What are expectations for the students who want to be placed in Math 201?
So if you want to start in Math 201, that means that you're not taking 111 and 112, meaning that you're not taking calculus and you're not taking the intro to analysis. So we really expect, again, this placements will happen through a conversation, one-on-one with one of us. But basically, we want to make sure that like you really know how to write proofs, how like have had some background on proofwriting, and also that you know the basics of like epsilon delta proofs for analysis types things. If you haven't heard this, don't worry, we would teach you that in 112, but if you're trying to skip 112, you should know that kind of thing. And many times what we realize, if someone has some serious experience with proofs, which a lot of people have coming out of high school, we might decide that you can start with 201, but we might suggest that you take 112 at the same time, so that like you really get like that solid foundation on proofs. And so that again, but maybe one thing that I really want to emphasize is that we try to make this a personalized kind of process, and it's not like a one size fits all. So we're having these conversations with students so that we can do what's best for the student. And if we decide to quote unquote hold you back, it's not because we're trying to hold you back, but because we think you'll be better off. We have seen cases in which maybe a student is like really wants to push to skip something, and then later on they realize that maybe they shouldn't have, and this is actually not good for the student. So we try to be very careful to make sure that if a student is skipping, it's because they're really ready and not because they're going to regret it later on.
Great, thank you. Do you think that Reed would be a good college for someone who wants to study math, statistics, and data science as a pathway to do original research in mathematical ecology or ecological economics?
That's a really fantastic question. I think yes is the answer. Through the program that we have here, in our departments, you certainly are going to get variety of or training and skills in writing proofs, thinking really logically, working with data, having various methods, all of the skills that a mathematician, a statistician, a data scientist might have. But something that Angélica said earlier, which I think is really to this question here, is that even after completing all of our requirements and all of our requirements for our general education here at Reed, you still have a lot of time to take courses in other fields and really diversify your knowledge. So perhaps at some large universities, you might end up spending well over half of your courses within your major department. Here, that's not necessarily the case. And if you come in with a really strong interest in something like ecology, we have courses in that. If you come in with an interest in something like economics, we have courses in that. And we really encourage you, in fact, to take courses in those other departments. And oftentimes that enriches the courses that you take within your major department. So maybe you decide you want to be a math major with a statistics concentration, but you've taken a few courses in ecology already. Then throughout your statistics courses, oftentimes you can use problems from ecology to serve as the foundation of a final project in a course. And I think that is part of the curriculum that like really enriches yourself as well as all your other students in the course, seeing the applications of our work in other fields. So the answer is a wholehearted yes.
Yeah, and maybe I should also say, I mean, I think I'm also talking about like past experience. So like even if you didn't take those classes, like maybe you were not thinking about this. I mean, if you were thinking about it, you should definitely like you can start your path towards that. But even if you didn't think about it, you just finish with your math major, and then you decide that you want to take that path. Again, like the idea of the math major is that it gives you a lot of tools for like critical thinking and creativity. And if you also take some statistics classes for handling data and whatnot, right? And then you've proven that you can learn. So one of the things that we teach you is how to learn yourself, right? And then many people maybe go and like take a year of classes somewhere to prepare themselves like to do that switch and take that career path. So if I go back and look at our list of alumni, we have people who graduated with math degrees that then went on and like did a PhD in genomics, right? Or whatnot. And it's not uncommon. And again, part of it is well, maybe you have to do a little bit of work in between to prepare yourself, but you don't have to like go back and do another undergraduate degree.
Great, thank you. I'm also cognizant that we have just 10 more minutes left, so I'm going to skip around with some of the questions. And if we are not able to get to your question, I will put the email address for the admission inbox, in which case you can shoot us an email with your question. I want to jump to a question that I think is kind of interesting here. And what does Reed's feedback slash, our grading model based feedback model system work with, like, how does that system work with the math program?
Depends on the faculty member. Everyone has different ways of doing it. I still give numerical scores to my exams, although they're somewhat broad. It's not like I'm taking 1 point off because like you missed a negative sign. That's not how I grade, but I have a system where 5 means everything's great, and 4 means there was a minor mistake, and 3 means like you had the general idea, but like maybe there was a major mistake. I have a colleague who uses the planetary system to grade exams. So like the closest you are to the sun, the better you did. But in addition to whatever we're doing to express if you were correct or not, we write a lot of feedback in your exams and in your homework, and we try to really explain like not only that you were wrong, but why were you wrong, and we really try to focus on the feedback and not just the grade. But there are grades at Reed, and but we try not to focus on that. And like what I've seen from my time being here, that students take that as what we really care about in this whole conversation is what you're learning and how you're learning it, and the exams are just a reflection of that process. But I'm curious to see what Michael has to say, given that this is his first year at Reed.
Yeah, I mean, it's definitely been a transition for me. So I think I follow a similar pattern to Angélica. I do provide numerical grades, especially in the places where it's most appropriate. When you ask a question and there's kind of a right answer and a wrong answer, it's valuable to get that feedback, whether or not you were correct. But in the places in statistics in which there's much more of an art to it, it can be somewhat wishy-washy. That's where the written feedback really comes in. And that's where I'm not necessarily saying like you got 94% of this correct or you got 99% of this correct. I think that in places like that, oftentimes my answer is much more like you did a really good job in these areas, and these other areas you didn't quite seem to acknowledge this potential issue in working with this type of data, and then we have a conversation about that. So that's the place where the written feedback or the verbal feedback really comes in. And then when I think about assigning a grade at the end, it's certainly not some sort of detailed mathematical calculation. It's really a consideration about overall how the student was doing in the course, and how they showed growth throughout the course.
Great, thank you. And what percentage of the overall grade in your department is dependent upon exams versus the homework?
This is
So again, this could, yeah, really vary.
instructor to instructor.
Yeah. In my courses, exams are pretty heavily de-emphasized. Usually I have a midterm and a final. Each of them constitutes between 5 and 15% of the grade. So it can be really quite minimal. I think this is maybe not the norm in our department or across the college, but that's what I do. For me, homework and projects are a much larger percentage of the grade because I think that's really where the learning happens.
And maybe to emphasize Michael's question, Michael's answer is that it really depends instructor to instructor. And for example, I don't tell students what the breakdown is. Some faculty do tell students what the breakdown is. I want students to engage with all parts of the learning, and I don't want them to be thinking like, okay, since the exam is 20% of my grade, then I need to be doing this in this exam in order to like get whatever grade in that class. That's not how read works, and that's not the point of learning. So I really want students to engage with all the pieces. So I don't really tell students like what is what. And to be honest, I tend to calculate the grade in like 4 or 5 different ways, and doesn't matter which formula I use, like the grade ends up being the same. And I think part of this is the reflection that if you're consciously doing your homework, you're probably also going to be doing fine in the exams. And so in a way, like these things are correlated, and Michael is probably gonna like yell at me for saying that, but yeah, I mean, like I think for most students everything speaks to each other, right? Like the exams and the homework and so on. So I tend to see very little difference between one and the other anyways.
Great, thank you. Do students at Reed participate in like any types of like math competitions, like Olympiads? And are there any, I know some majors at Reed have like student groups sort of attached to a major, or at least academic-based groups on campus. Are there any that are related to the math department?
So there's the national undergraduate math problem solving competition is called the Putnam exam. It happens every December, and we do participate in it. And we usually have a faculty member who runs training sessions for it throughout a few weeks during the fall. And this is very much like low stakes, like we don't care whether you do well or not, but if you just want to have fun and participate and train with other people who are interested in that, then we're happy to provide a space for that. But as I said, like it's not like you're gonna get a better grade if you did this or not. It's just kind of like student interest. We do have a student group, which actually it's so we have a group of students that serves as facilitators for communication between faculty and students. It's called the Student Liaison Mathematics and Statistics Group, and the idea is that they run events so that students can socialize with each other, but also faculty can socialize with students. And then in addition, students can voice concerns about things that are happening in their classes, and they'll communicate them with the faculty. So that they serve as a channel as well. But this is a group of students that is selected to do this role, to have this role, and then they do try to have events so that students can socialize.
Great, awesome. And then are students able to see what textbooks that you all use ahead of time? Or can you talk a little bit more about like some of the books that you use in the program?
I mean, I don't know the actual system. So if you want to look this up, I mean, like I know the Read bookstore tends to have a list of like the books that people are using, but I don't know if this is accessible to people outside of Read. But many of us have websites for our classes, and you can look there. Although not all of us update those as often as maybe we should, because we just have like we have a system called Moodle where we can post things for classes. So some people might not have websites for their classes. That being said, many of us use in-house notes for our classes. Like, for example, for the current class that I'm teaching, I'm using the notes that were written by my colleagues when they were teaching the class, and that's not uncommon for some of the classes that read. But sometimes we also just use standard textbooks, and we try as much as possible to have textbooks that are open access, but sometimes the best textbook is not open access. So we try to be conscious of price, but sometimes that's not quite an option. I don't know, Michael, if you have something to add.
Yeah, I would say that if you're interested in figuring out the textbook that a professor is using for a course, I would just encourage you to email them. They'll probably let you know. I think there could be a lot of variation between various offerings of a course, but usually they'll give you a sense of the type of things that'll be covered. And then additionally, even if you hear or can find a textbook on a website somewhere for a certain course, know that that's not necessarily like precisely what will be covered. Because I think that our sequence of mathematics and statistics courses here doesn't necessarily follow like a really traditional mathematics or statistics curriculum. Oftentimes this means that we can cover a lot more than what are in the traditional, or that are the traditional topics for a course. So an example of this is if you take our probability course here, our students who are taking this course have taken a lot more mathematics courses involving proofs than a traditional probability student has. So when they take that course, we move through a traditional probability textbook, but we can do a lot more than what's in that textbook. So just be aware of that.
Awesome, thank you. Our last question for this hour, what advice would you give students who are considering pursuing math math stats or math CS at Reed? What advice would you give those students?
I mean, I think just get started when you come in, right? So like get a taste of what things are by either taking Math 111 or Math 112 or Math 113 or Math 141, right? Just to get started. Even if you end up not being a math major, these classes will count towards the general distribution requirements. So it's not like you're wasting time, whatever that means, and it can give you a taste of what the major is like.
Yeah, I would say to try out a few of our different intro level courses. So on the math side, we have calculus, we have discrete math. On the statistics side, we have probability and statistics. Try out a few of these, 2 or 3 of them, and see what you like. There's a lot of variety there. They serve as prerequisites for other types of courses. And you might find that you really love discrete math, then you can kind of go down that path and see the other courses that are available afterwards. Maybe decide that one of these things is not really for you, and that also can be really illuminating. So, as Angélica said, these still serve for your general education requirements, even if you decide this isn't the right place for you. So either way, no time wasted.
Awesome. Thank you both so much for taking time to talk a little bit more about the math and statistics program here at Reed. I know I found this enlightening, so I'm sure our students who are attending the session or watching this video in the future will also find this enlightening. For those of you that attended the session and asked the questions, a huge thank you so much for your participation in this process. I did put the contact information for the admission inbox in the chat box, so if I didn't get to your question, I apologize, but feel free to reach out and connect with your admission counselor, and we'll do our best to get you an answer. Otherwise, this video will be up on our YouTube page within the week, so you can rewatch it over and over and over again. And you all have a great rest of your day. Thank you so much.
Thank you for coming.
Yeah, thank you all.